Hello, hello.
Hi there.
How are you doing?
Good. How about you?
Good. Likewise. We are making good progress as usual on the slow side, but that just reflects my optimism. Um, yeah, I'd say there's one big piece missing, big piece, not even that big, before we reach parity in terms of features with what we want to launch mainnet with. This piece is um, we want to have isochrone mining pipelines. And so we analyzed the situation for mining, and it turns out that there are certain configurations that a miner could configure their machine into that cause them to mine faster than others. And so we want to eliminate that option. And
So
that's the last thing.
isochrone referring to iso means like the same and chrone is time. So you want
Yes,
miners to mine in sort of the same time scale.
correct. And so this refers to the composing step because composing is stateful, whereas the guessing step is stateless. And so it doesn't make any sense to make the guessing step take the same time because
Okay.
as soon as
Could
you
you
make one guess,
just
you have a probability of
could you
success.
just rehash, no pun intended, what those two steps are?
Right. In the first step, which is composing, you assemble transactions, you aggregate those transactions, so you throw out the original proofs and you replace them with a single proof for the entire batch of transactions that the original proofs were correct. And that single huge aggregate transaction turns into a block, and the transaction proof turns into a block proof. But the point is that the block comes from making a selection of transactions from the miner's mempool, and it involves a lot of proving. So that's the composing step. The guessing step is where you contribute the proof of work. This is where you select a nonce, and if this nonce is such that the hash of the block is smaller than the target, then you have found a block, and everyone has an incentive to switch to this new block. And the way it works is there is a block subsidy that is determined by the block height. This block subsidy follows a exponentially decreasing curve, so
Hang
we
on,
have a
just
finite
to get step
supply.
by step.
Please.
What is the block height?
Well, the blockchain grows upwards. So if
Okay.
it starts at zero, the next block has height one, the next block has height two, and so on.
Okay.
Um, right, and so this block subsidy has an exponentially decaying issuance rate, meaning that the total limit of coins is finite. Now, of this block subsidy, the composer can allocate to himself or to the guesser at the discretion of the composer. The composer can then
I think we
go
need to
ahead.
slow it down. So the block subsidy is that the block reward, like the reward for mining, or what is?
In my conception of things, the block reward includes the transaction fee
Okay.
because both things are rewarded to the miners. Um, and, and by the way, the it's a simple addition. We don't treat the transaction fee as different from the block subsidy. So the block subsidy is just a number that you are allowed to violate the no inflation equation by. Um, and so the which proportion of the block reward goes to the composer is at the discretion of the composer. Having produced a block proposal, the composer can opt to disseminate it, broadcast it, and guessers who are receptive to that sort of thing can receive these block proposals and start guessing on it. And
And
if they
are
go
you
ahead,
expecting it not to be the same person or the same node?
correct, because composing requires beefy hardware. Uh, 50, 60 CPUs, 150 gigabytes of RAM. That's that order of magnitude, and it's even worse than that because if you have double the number of CPUs, then up to a limit you'll be able to compose twice as fast. And I don't think there's anything we can do about that right now, unfortunately.
Okay,
On
but
the other
how
hand,
is the guessing not hardware constrained?
well, you can do it on very weak hardware.
But can't you do it more quickly in succession with better hardware?
Yes, you can, um, but the point is that you don't need a 64 core AMD Threadripper to do guessing.
Okay,
We can do guessing on this rather relatively weak
because
laptop. We can do guessing on my Raspberry Pi, which certainly cannot produce complicated proofs.
okay, so it cannot compose, but it can do the guessing step.
Correct. And so many more people can participate in guessing. And guessing is also embarrassingly parallelizable. If you have a GPU cluster, well, assuming that somebody writes the GPU code, you would be able to distribute it to every single core in every single GPU of that cluster. Um, whereas composing, yes, you would be able to accelerate composing with GPUs too, but not in the same sense.
But didn't you start this whole story by saying that you wanted, or you guys wanted the mining to be isochrone so that it's sort of independent of hardware?
Well, it's difficult to make it independent of hardware, but it should be independent of the particular configuration that you choose when you set your configurations. We want to assemble a block with this many inputs, that many outputs. We want to merge 6 or 7 times. Uh, there's a lot of choices involved when you produce a block, and we want the um, time it takes to produce a block not to benefit producing empty blocks. So basically, we don't want to incentivize composers to produce empty blocks, and that's it.
Okay.
And right now, unfortunately, it is faster to compose empty blocks than non-empty blocks.
Okay. So you don't want to incentivize composing empty blocks. So in other words, you want to incentivize filling blocks.
Well, filling sounds as though they're going to be almost full, but if there are transactions in the mempool, then miners should include those transactions.
Okay.
Whereas now they can only do so by incurring a disadvantage
Gotcha.
relative to other miners in finding the next block.
Okay.
Um, yeah, and so the guessing step is more similar to what people think of as mining on Bitcoin or what have you. But the fee that goes to the guesser is determined by the composer. And so if you have an ASIC for composing, supposing that this exists, and you can compose in 1 microsecond, and this is 2 minutes faster than the next best thing, then you can um, allocate the lion's share of the block reward to yourself because guessers will start guessing with a 2 minutes head start over on your block proposal over the block proposal coming from the competition.
Mhm.
So there's a price dynamic there that's hopefully going to regulate um, uh, composing versus guessing.
So in other words, for a guesser, if you start guessing on that on the composition of this quick hardware, let's say this powerful hardware, you're more likely to win, and therefore the price should be adjusted downwards. That's what you're saying.
Exactly, exactly.
Okay.
So there is a premium to faster proposals. So
And
we
why
still
why
want, go ahead.
why can't they guess themselves?
They obviously can, but maybe the available guessing power on the entire network dwarfs the available guessing power that they have by themselves. And in order to find a block, you need both the composition and the guess to be correct. And
Okay.
so these fast composers will want to leverage the big guessing power that the rest of the network can provide.
So what? So is are you sort of getting rid of the metaphor of mining?
We try to avoid using that word. Um, just that. It was only a metaphor to begin with.
Yeah. Obviously, yeah.
So it's interesting to see where the law will fall once they realize that um, the mining process is what obfuscates the traces of transactions and generates privacy. But the law, at least as far as I'm aware of it, explicitly allows for mining. And so there's a potential conflict there, and maybe the way that conflict is going to be resolved is by separating composition from guessing. I think it would be a rather artificial separation because there is no consensus generating power to mere compositions. The reason why you have an incentive to throw out whatever you were mining on and continue with the block that has the correct nonce is because you know that everybody is doing this. Um, the fact that the, guessing is hard and stateless means that there is no advantage to ignore the fact that somebody else was successful in guessing. And that's the key feature that generates consensus. So guessing is absolutely an essential piece of the puzzle.
That sounds important, but I didn't get it. Could you explain it in a different way?
I can try. Um, what would happen if we were to drop the guessing step altogether, right? And the first thing that will happen is that whoever has the fastest composer will always win the block reward, and that's not the thing I want to focus on. So we're assuming that there is no guessing step, and we're also assuming that everyone is equally fast up to a negligible margin in terms of composing. Then the question is, somebody finds a block proposal, and I'm 99% done with my block proposal. Why would I switch to this incoming block proposal? I would just spend the epsilon extra effort in completing mine, and then I have a counter proposal that's just as good as the one that came in. And I might even win the block race if I start disseminating it and have a slightly better connected node. And so this situation
So
devolves into a
this
constant family of block races.
so there's no incentive to converge.
There is no incentive to converge. The
Okay.
incentive to converge comes from proof of work, and specifically because it is stateless. a new block with proof of work comes in, or if you will, with the correct guess comes in, well, since in order to find a counter proposal with the same qualities, I would have to spend the next 10 minutes with all the mining power of the network, all the guessing power of the network, to find some, to have an expectation, a reasonable expectation of finding something um, with the same quality as the incoming block. And by the way, by that time, in expectation, the rest of the network will have found a new block. So that's where the incentive to converge to a consensus comes from. It's because people have no incentive to ignore the incoming proof of work because they cannot replicate it. They cannot be 99% of the way done. There's no such thing because there is no state.
So the last part, I'm not sure I understand because you just started by saying that they were 99% done, but then you ended by saying that there's no such thing.
In guessing step,
Okay, the guessing's binary because you get it or you don't.
you get it or you don't. Yes, there's no
But
such thing as halfway done. Yes.
then that sounds kind of like sounds like state. So what do you mean when you say there's no state?
There's no state besides done or not done. The state
Okay.
is one bit.
Okay. Okay. And I'm just okay. So I understand how there's an incentive there that gets that's created because you've let's say if you finish your composition, you just need to do the guessing step, but then there's a already composed transaction with the correct guess. Even then, you would have to discard it because you know everyone's going to continue on top of that, and I'm going to have to spend time. I'm going to have to spend time guessing, and that's the proof of work that you're
Exactly.
referring to. Yeah. Okay. Yeah. Amazing.
So yeah, whether it's going to work well in practice is something that obviously has to be observed. But I'm eager to run that experiment.
Right, and so just to reiterate one more time, so then if you remove the guessing step, then a block might be finished. You're like, oh fuck it, let's send mine out anyway, and so everyone's competing, and then there's presumably no convergence. Yeah, interesting.
Exactly correct.
Okay,
And
that's it.
of course, without the composing step, there's nothing to guess on.
Yeah.
So I think the two steps are inseparable, um, integral components to mining. Um, so yeah, I think that separation it helps developers, but I think if a legal person would try to use that separation, it would be kind of moot because they're both producing blocks.
Okay, and does that have any implications in terms of I don't know, I guess like network usage and just because it kind of sounds like you're splitting something that's a single sort of action on the Bitcoin network, for instance, into at least two actions here, right? Does that
Well, I think even on Bitcoin, miners make a selection of transactions to include into their block from the mempool. What miners on Bitcoin are not doing is proving. So,
they're making a
to the
select?
extent that there is a separation between two steps in Neptune, the same separation exists on Bitcoin.
But the miners on Bitcoin that collect transactions from the mempool, they're not transmitting that collection and waiting for an answer, right?
They're not transmitting that. Yes, they are. That's what a block is.
Well, eventually, but not before, because then they're done. Whereas,
Right. They're not broadcasting halfway done blocks. Yes.
yeah,
Whereas on Neptune they are. Yes. Correct.
okay. And maybe one more follow-up question. So that means that the person or the node with the beefiest hardware, let's say, they can just dictate what gets composed. So they can compose blocks however they want, and then they give the guessers the head start, and they tend to sort of dominate how blocks get composed. Is
Well,
that
let's run through this experiment, right? You are sitting on hardware that is twice as beefy as mine. So let's say it takes you 2 minutes to produce a block proposal, and it takes me 4 minutes to produce a block proposal. You allocate to yourself 90% of the block reward, and I allocate to myself 40% of the block reward. And so when I'm done, 2 minutes after you, I broadcast my block proposal, and all the guessers on the network, they can see a more profitable to them block proposal, and so they'll switch to mine.
That's interesting. And so they could tweak that parameter like algorithmically or manually, however they would want. Okay.
Correct.
Yeah, very interesting. All right. I think that should cause at least some heads to explode.
Yeah, I'm sure it's a great academic question too, but I'm really looking forward to the real life experiment.
Yeah, me too. All right, cool.
All right, take
So,
care. Bye bye.